model is trained based upon those data. So uh, that's how the model is so much powerful. So it's not just because of the architecture or the algorithm of the model. Uh, these algorithms are pretty much same or somewhat enhanced version of how deep neural network is constructed. Algorithm itself is not that something revolutionizing. So the one thing is the data, and the second thing is the hardware. So basically, earlier on, in order to crunch such a huge data, which are in terms of petabytes, not gigabyte, not terabyte, but petabytes of data, needed super computer, which were only accessible to the government or and very and it had very restricted usage for very critical application. And for these kind of research oriented, was only made possible because of the how for last 10 year, the Nvidia company, the company behind the graphics GPU, were working on developing their enhancing their GPU, and as well as the code base, to provide a massive parallel computation, specifically very highly optimized matrix transformation. So basically, what exactly all the deep learning model, or in fact a simple neural network model, does is, or in fact, if you consider simple linear regression, what exactly it does is it find weight. What is the, it tries to fit the equation, tries to find the equation. And so basically it is done by adjusting the variable. So so that's what the training is all about. It has to find the value which fits all the data point, or you can say it moves the data point in appropriate location. So now those two things made it possible. Um, the 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 data set, the textual data set, and the GPU. So here, whatever the LLM model you use, whether it is cloud or whether it is ChatGPT, Gemini, Grok, DeepSeek, uh, uh, whatever the Chinese other model are there, Z.AI, and the other popular. There are plenty of very much popular model out there. So all those models are based on somewhat similar architecture. So basically, the underlying core architecture is same. Uh, what they do tweak is the training data set, and the post tuning, the post training is where you uh, first step is you pre-train based on the text corpus, and then you in post training setup you converse with the chat, whatever the chat bot is or the LLM model is. You provide the input, and you provide the what is the expected output. So based on that, it gets fine tuned. So that is the next powerful thing, which makes the model much more accurate and powerful compared to the other LLM models. Anyway, so basically, so that's the thing. And so in order to learn about um, strategy is to use the Hugging Face library and the models hosted on the Hugging Face. So huggingface.co is a you can say it does a lot of things. So the first thing what it does is it provides infrastructure to host the open source or open weight model. uh, how like for example, like how GitHub is for the open source community, where anyone can host their code, share their code uh, throughout the community. Similarly, for sharing weight, Hugging Face has become standard. Uh, and the reason is why there are there there no why it has become standard, because model size tends to be around in terms of either GB or TB. For example, if you look at zai.org GLM, this is one of the right now most accurate and popular open source, not open source, open weight. There is a difference between open source and open weight. Open source model are the model which uh, release their complete code, exactly how they trained, how they fine tuned, how they uh, tweaked their architecture, or how they clean their data source. Even their data source are open. So those architecture are called as open sourced architecture. And then there are open weight architecture. Right now, there are companies which are providing open weight architecture. Very few companies are providing open source uh, model. And the open weight model are those model which an organization or a company provides the trained model which anyone can use free of cost. So you can use the model to further fine tune it, but you really don't have any idea how the model was trained. So most of the, for example, Meta also has Llama, and Google also has a open weight model called Germa, and GLM is also open weight. All the Chinese model are open weight model. So if we look at the size of the model, so here, so there are 282 files, and each file is 5 GB, 5.34. So you can calculate, it comes to around uh, terabyte of data, or maybe, yeah, terabyte of data. If you calculate it, 5.38 into 250, 82, 282, 282. So it will be around 1.5 terabyte of data. So basically, anyone can go ahead and download this model free of cost, and their infrastructure is very efficient to download these model. But the only limitation is that you can't run these model on your computer, because it requires, the size of the model dictates that it needs at least 1.5 terabyte of virtual GPU RAM. Um, so basically, then that means that you need at least hundreds of GPU, which is very costly affair. So what we will be using for learning session, we will be using some base model which are small in size. For example, BERT, Distilbert, Roberta, and all those kind of models are very quite efficient for learning. So one thing is Hugging Face provides the model, and the other is the data set. So data sets are kind of collection of your text, uh, text with a uh, either it is in time of structured data set. For example, you can see that it has column called header content, uh, and so on. Or if it is specifically for text-based model. So if you look at for example, I think this is distilled model. So here you can see that directly message structure is there. And so what this kind of data set is, this is called the distilled model, where from the already existing Cloud Opus message was sent, and what was the reply, it was recorded. So rather than the content directly from web or from your book, the data is directly from another chatbot, which is called as distilled data set. So you can you might go through the data set, and you will find a wide variety of data set. And it is not limited to text. You can see that there are audio, document, geospatial, video based data, image based data. So those are the second thing what Hugging Face provide. And the spaces where so it provides an infrastructure where you can host your model uh, for inference, so that you can use it in your web application, or you can use it as a chatbot. So that's the third thing. And the fourth thing what they provide is the Python libraries in order to load the model's data set and write application to use those existing model. So so that's what we are going to learn today. We are going to use Hugging Face model. Sorry, we are going to use Hugging Face library to load the pre-trained model and do certain text-based application. So the first thing. Okay. So here, the first thing is that you should make sure that the transformer library is installed on your machine, as well as the torch. The torch is called as the PyTorch library, and it is from the Meta. So here, the transformer library provides the logic to load the model from Hugging Face, to fine tune your model to and it provides the pipeline infrastructure to write code in minimal few lines of code to build application out of the model. And the torch is the main library which is responsible to exactly load the model into the GPU or to the CPU, and to do all the complex mathematical operation. So you can understand this way, that torch is a library to help implement parallel computing. And if GPU are available, then it uses GPU in order to do the parallel computing. So transformer model either use PyTorch or the TensorFlow, which is another matrix transformation, and you can say parallel computing library. So here, so basically PyTorch is a kind of standard library. It has become kind of standard library to interact with the GPU and do parallel computation. So these two libraries are required. So if you are using the Google Colab, then you can use the GPU, uh, which will help you speed up the coding. In order to execute the code, it will speed up that thing. So either use GPU or TPU, whatever is available. So here it will connect, will take some time, and then So I see certain error. So now it says that I have access to the CUDA. That is, I can access the GPU, and so it shows the version why what Tensor, PyTorch, and Transformer version is. So now let's dive into the easiest way to use Transformer pipeline. Pipeline abstract away all the complexity and let us use AI model in just 2-3 lines of code. So you can think of pipeline as a complete workflow. It takes your raw text, process it, and sends through the model and gives you human readable text. So let's see the transformer into action, and we will do the simple sentiment analysis. So here, so here, in order to use pipeline, we will import pipeline from the transformer. We will initialize the pipeline with what depending on the task what we want to perform. Here, the task the task is not only limited to text-based tasks, natural language processing based tasks, but it can be multimodal. That is, it can do audio text to text, image text to text, computer vision, uh, audio based tasks, tableau tasks. So there are different kind of tasks, but what we are focused today are natural language processing based tasks: text classification, token classification, table question answering, text generation, and so on. So sentiment analysis is one of the natural language processing tasks where uh, the model takes a text input and it classifies the text into either a kind of label of positive or negative. It totally depends on the kind of model what we are using. Here, uh, the model by default, what it will use is BERT. So BERT will output the label and the score. Higher the score, so the score is between 0 and 1, and the higher the score, the more confident the model is about the result. So, so here, in order to instantiate the model, we import the pipeline and then specify our task. Here, the model name can be provided, which is an optional, which is an optional. So we'll leave it over here, and we will let the pipeline itself to choose the best optimal model based on the task. After that, the when we create the pipeline based on the task, so the model instance is now available. We can use it to feed the data and directly get the result. So here, just 2 lines of code. Here, initializing the pipeline, what task is, and we can further fine tune it, and we can further provide model, what model we want to use, and then use the model to get the result, whatever based on our input. So these are the, just in 2 lines, we can get our sentiment analysis ready. So here in the second part, we are doing the same thing, but with multiple text. And here we are getting the result in one go for all the text. And we are iterating over the result and printing it. So let's see. So here the model is getting loaded. So when you run the pipeline, so for the first time, if model is not available, then it downloads the model, and then it um, gets the then executes the model and then gets the output. So you can see that the for the text, the product is fantastic, sentiment positive, confidence score. I am disappointed with the service, negative, confidence. The weather is okay today, positive, with that 0.998 as the confidence level. So you can see that such a powerful thing, the sentiment analysis, which is widely used today for different brands to do the real-time analytics of LinkedIn or Twitter, to see how their brand is perceived. Now, let's look into what are the different tasks are there. So here, so these are the few tasks: sentiment analysis, classified which classified text as positive, negative, text classification, general text classification, NER, named entity recognition, which we'll look into that thing, question answering, answering question based on context, text generation, summarization, translation, fill mask, zero shot classification, teacher extraction, question answering. So these are some of the tasks which we can implement using the transformer library and these pre-trained model. So here, let's specify another model. So here, I have specified another model, BERT-based multilingual uncased sentiment, which is provided by NLP Town, which was trained by NLP Town. So if we look at, so here still we are doing the sentiment analysis, but here if we provide the text to the classifier instance, then it provides, rather than positive, negative, it provides in the terms of star rating between 0 and 5. And the other model, emotion English detection, it detects the emotion. So for that we use text classification, and it detects the detection, and classify into joy, happiness, sadness, and so on. So here for this text, I just got promoted at work, surprise, and for score 0.46, and the food was awesome, delicious, label as a 5 star, and score as 0.62. So the output what we are seeing here, that is the output as in the final output, is defined during the training. So in short, the output is determined by the model, and each and every model might have their own structure to the output. So you can go ahead and refer to the documentation to get, if whatever the model you are using, you can go to the, you can go to the model documentation and see what are the labels. For example, for this Hartman, uh, these are the labels: anger, disgust, fear, joy, neutral, sadness, surprise. And also, also uh, some of the model card might provide sample code, how to fine tune it, and so on. For example, here they have the sample code in order to how to use the model. So, and it gives in depth how the model was created. For example, the model is fine tuned checkpoint of Distelbert. So it is not trained from the scratch. It is fine tuned version of another pre-trained model. So, and here you can see the sheer size of the number of model hosted on here. So there are around 28 lakh model. So based on task, you can go ahead and try things on your own. So now let's get uh, in under the hood. So let's try to understand how these transformer work. We won't go into the algorithm. We'll just try to understand the basic working. So before any text goes into transformer model, it needs to be converted into number. Why? Because the computer, the underlying thing which which makes these deep learning neural network uh, compute, or you can say build a model or find the weight, is based on mathematical computation. So under the hood, everything is nothing but vector, and vector being transformed. So here, from this, we understand that the first thing we need to do with the text is to convert into the number, and before converting into the vector, so that these model can uh, move to transform it to the proper location, that is, move similar word closer and dissimilar word or opposite word in opposite action. So before it does that thing, what it does it is it breaks the word into token. So for example, let's say, so here let's say this is our text: hello, I am learning about transformer. Now the model don't maintain does not maintain all the word. For example, uh, it won't for example here, um, unhappy. For example, a word unhappy. Transform the model might represent only happy, and it might use un in a as a separate thing, which makes during the model inference, it makes a word un and happy in opposite direction of all the happiness related word. So so basically it doesn't maintain each and every word which it encounters during the training, because for example, there might be spelling mistake, there might be some very rare word which is not used at all. uh, Also there are different languages, and so if we consider all the scenario, then in order to maintain each and every word as a vocabulary will be very inefficient for model to compute. So basically what it does it, uh, m- model during the training prepares a dictionary based on the input text whatever was provided, and it finds a pattern and tries to break the word into sub part and tries to see if it has meaning. And if that is mean, what do we mean by meaning in the term related with the transformer, is that a relationship can be established with the other word. So here you can see that although the text hello comma was is considered as a uh, second token, in the third word is I am, but I is considered as a token, apostrophe is considered as another token, and m is considered as another token. So here the text is very simple, and for example, happy because uh, okay, my C is not working, but anyways, so here you can see that I am, in this case, unhappy is kept as and because C is, sorry, not working. So what can be done? Uh, Actually, I'm having keyboard issue with related with the keyboard. But anyways, you can see that how the uh, because and it's and everything is broken. So basically, tokenizer are the thing which breaks the sentence into uh, sub word, which can be fed to the model so that it can do the matrix transformation and do whatever the computation is required. It can do on those things. So actually, I'm having certain issue with my keyboard, and let me just provide you one example over here, and we will conclude our session. And in second session, which is related with the uh, natural language processing, I will cover the rest. Meanwhile, let me What I will do, I will just put an example task. So here we are going to see one of the example of named entity recognition, and the named entity recognition. What it does is it takes the text input as the context and extract the all the named entities. That is the name of the place, organization name, location name, uh, maybe if date is there, person, then and other thing, for example, technology related thing into miscellaneous. So let's see this thing into action. So this is the context. Here we are using the same pipeline how we used to create the classifier. Here, instead of sentiment analysis, we will provide NER as the task. Aggregator strategy, we will keep it as simple. And then to this NER pipeline, we will feed the text, and then we will iterate over the output. Here, entities are the output, and we will iterate it and format the output. Here you can see the output. Uh, from the text, it was able to extract Apple Incorporated as organization, Steve Jobs as a person, Cupertino as a location, California location, Tim Cook as a person, iPhone as a miscellaneous. And you can tweak uh, tweak it with your own context, and you can try it on your own to understand how it is able to extract the named entity. So in today's session, we I'm just uh, closing at this stage. But in our next natural language processing session, what we are going to cover is we are going to cover more in depth of the tokenization, more about how the transformer model work, and more we will see more of uh, application of transformer model, and also we will try to do the fine tuning. But today, because of issue related with my hardware, I'm just closing my session today. Bye bye, and see you later in next session.